Hi everybody. I apologize for not being in class the past couple days. I was homesick yesterday, and then today I actually have peer leadership selection. But because of technology, I was able to actually video today's lesson so that way you guys don't fall further behind. So today you're going to be learning about unit vectors. A unit vector is defined as a vector whose magnitude is 1 unit long. Very similar to how the unit circle is a circle whose radius is 1 unit long. So basically what we're going to be doing is we're going to be taking vectors, information about vectors, and then rescaling them so that way the vector is only has a length of 1 unit as opposed to another length. So basically we're going to be shrinking down our vectors so that the hypotenuse or the magnitude is 1. So in this first example, we want to write the component form of a unit vector in the same direction as vector A, which is defined as the x component being -5 and the y component being -7. So always when you're talking about vectors, my recommendation would be to draw a diagram of the vector. So if we know that our x component is -5 and our y component is -7, x and y are both negative in quadrant 3. So I'm going to go ahead and draw my vector down here in quadrant 3. And then I always like to turn my vectors into a right triangle by drawing a height to the x-axis. I would really discourage you guys from drawing to the y because things could get kind of confusing with what you know from unit circle trig or SOHCAHTOA and everything. So always draw your height to the x-axis. And I'm going to label these side lengths -5 and -7. So if we want this hypotenuse or this magnitude of this vector to be 1 unit long, because that's what a unit vector is, let's figure out what it is right now and then we can go through and resize it. So what we're going to do is let's go ahead and do Pythagorean theorem to figure out what the hypotenuse of this right triangle is. So if we do 7 squared plus 5 squared equals c squared, we don't have to worry about putting the negatives in because if you square a negative, it just turns positive anyways. So 7 squared is going to be 49. 5 squared is 25 equals c squared. 49 plus 25 gives us 74. And then if we square root that, we get c equals the square root of 74. So that's what this hypotenuse length currently is, which would end up being a decimal somewhere between 8 and 9. But I'm just going to have you guys leave it as the square root of 74. So now what we need to do is we need to shrink down this vector so that it goes from having a length of a square root of 74 to having a length of 1. So to do that, you can rescale that vector by just dividing by the square root of 74, because the square root of 74 divided by the square root of 74 just equals 1. If I do that, though, with the hypotenuse, to keep this triangle in the same scale, we have to divide the x component also by the square root of 74 and the y component also by the square root of 74. So when the directions ask us to write the component form of a unit vector in the same direction as this vector, we have our x and y components. Now we just have to rationalize the denominators because it's bad math manners to have a square root on the bottom. So our x component, -5 over the square root of 74, if we multiply top and bottom by the square root of 74 to rationalize that, that would give us -5 root 74 over 74, which would be our new x component of our rescaled or resized vector. And then our y component is -7 over the square root of 74, which if we multiply top and bottom by the square root of 74 to rationalize that, that would give us a new y component of -7 times the square root of 74 over 74. So if we wanted to finish this problem off by writing the component form of this unit vector, so this our original vector resized so that the magnitude is 1, the x component, -5 root 74 over 74, the y component, -7 root 74 over 74. There we go. So basically all you're doing, once you know all three sides of your triangle, after you turn the vector into a triangle, again, you're just going to resize the magnitude or the hypotenuse of the vector to get it to equal 1. So you just divide by whatever that side length is, because anything divided by itself is 1. And then if you do that to the hypotenuse, you must also do that same thing to the x and y components. Okay? So that is example number 1, where you were given a vector in component form to turn it into a unit vector. But what if you're not given a vector in component form? Let's say, for example, in example number 2 here, let's say we wanted to find the component form of a unit vector in the same direction of a vector, but let's say that this vector now, instead of being given in component form, we just know the magnitude and the standard angle. The process is still the same, as we're still going to divide all three sides of the triangle by the magnitude or the hypotenuse of the vector. It's just going about finding the information about the triangle might be a little bit different. So again, I always recommend drawing a picture of the situation that you're dealing with. So now we have a magnitude, or a vector with a magnitude of 8 and a standard angle of 290 degrees. So let's figure out where that is. Okay, so standard angle, remember, is from the positive x-axis counterclockwise to the vector. So if I start here and go counterclockwise 290 degrees, let's see. So if I go from here to here, that's 90, 180, 270. So I have to go 20 degrees more to get to my vector. So that would put me about here. Okay. So this angle right here is 20 degrees. And like I was talking about in the previous example, I'm going to turn this into a right triangle by drawing a height to the x-axis. You guys are going to be tempted to try to draw across to the y-axis, but it'll be less confusing for you guys if you go to the x-axis. Okay? So I know that my hypotenuse, or my magnitude of my vector, is 8. So I'm going to label this right here as 8. And I know this angle outside of the triangle is 20 degrees. So if I wanted to find this angle inside the triangle, we know that the 20 degrees and then this angle have to equal 90, have to add together to be 90, because that's what this quadrant is, 90 degrees. So 90 minus 20 gives us this angle right here of 70 degrees. Okay, so we know if we want to turn this into a unit vector, we have to divide all three sides by 8 to get this vector to have a length of 1 unit long. But we can't do that yet because we don't know the x and y components. So let's figure out the x and y components first. So there's x, there's the y component. So what we're going to do is we're going to use SOHCAHTOA to figure that out. Let's start with the x. The x from the 70-degree angle is adjacent, and the 8 is the hypotenuse. So let's go ahead and use cosine to find the x, because cosine is adjacent over hypotenuse. So if we have the cosine of 70 degrees is going to equal x over 8. And then you have to multiply both sides by 8 to get x by itself. So in your calculator, if you do 8 times the cosine of 70, you should get 2.74. So my x component currently is 2.74, and that's in the positive direction, so I'm going to keep that as positive 2.74. If we wanted to do something similar to find the y component, but from the 70-degree angle, the y is the opposite, on the opposite side of the triangle, so we're going to use sine to find y, because sine is opposite over hypotenuse. So you're going to have the sine of 70 degrees equals y over 8. And then multiply both sides by 8 to get y by itself. So in your calculator, if you did 8 times the sine of 70, you should get 7.52. And when I go to label it in my diagram, I notice that it's in the negative y direction. So y is going to equal negative 7.52. Okay? So now that we have the information about all three sides of the triangle, I can go ahead and rescale this vector so that it becomes a unit vector, which means we want the hypotenuse or the magnitude of the vector to only be 1 unit long. To do that, since my magnitude is currently 8, let's divide that by 8, because 8 divided by 8 equals 1. But if I divide the hypotenuse by 8, I must also divide the other two sides of the triangle by 8. Normally, it's kind of bad manners to have a decimal within a fraction, but I'm okay with you guys just leaving it like that. So now we have our x and y components of our unit vector. So the last step would just be to write it in component form. So here, the x component is going to be 2.74 over 8. And then our y component would be negative 7.52 over 8. There you go. So those are the two examples that I have for you guys. I actually have two problems that I would like for you to go ahead and try on your own. So at this time, if you could, go ahead and take out a piece of scratch paper and a writing utensil and a calculator if you haven't already done so. Maybe you were kind of taking notes on what I was just talking about with the examples. If not, go ahead and take out a piece of paper now. What I'm going to have you guys do is go ahead and pause this video so that you could try these two problems. And then when you're done, unpause the video and I'll take you through the solutions step by step. So go ahead and pause the video now. Okay, so by now you should have tried these two problems. Hopefully you guys paused the video, tried the two problems, and now you're coming back to check your answers. So here are the solutions that I have for these particular problems. So for problem number 1, when the component form was negative 5, 3, I went ahead and drew a picture of a vector whose x component was negative 5, y component was positive 3. Over here, I did the Pythagorean theorem to find that the hypotenuse length, or the magnitude of the vector, was the square root of 34. So now that we know that the hypotenuse length is the square root of 34, we could divide all three sides by the square root of 34 to rescale or resize my vector to be a unit vector with 1 unit long. So when you do that, and you divide the x and y components, I have x down here and y down here showing the rationalizing of the denominator, but after you rationalize, you should get an x component of negative 5 root 34 over 34, and a y component of 3 times the square root of 34 over 34. So that was the first problem you were to try on your own. In the second problem that I had you guys go ahead and try on your own, I gave you that the magnitude of a vector had a length of 12 and the standard angle was 215 degrees. So that puts your vector in quadrant 3, where the angle inside the triangle right here is 35 degrees, and then the hypotenuse is 12. So I use SOHCAHTOA to find the missing x and y components. So your x component was negative 9.83. Your y component should have been negative 6.88. Don't forget to put those negatives in with your diagram. That's the number one mistake that I will see students make, is forgetting those negative signs. So please don't forget those. Okay, so now that I knew all the information about the triangle, we could go ahead and rescale or resize the length of this vector to be 1 so that it's a unit vector. So to do that, since the magnitude was 12, I just divided it by 12, because 12 divided by 12 is 1. Since I divided the hypotenuse by 12, I had to divide the other two sides by 12 as well. So the x component of your unit vector is negative 9.83 over 12. And then the y component of the unit vector is negative 6.88 over 12. Okay. So that's it for today's lesson on video. What I'm going to have you guys do now is to go ahead and look at the announcement for today on Google Classroom to find out what your homework assignment is. And then you should use the rest of the class time to go ahead and get started on that homework assignment or getting caught up on any other homework assignments from this chapter that you're maybe a little bit behind on. But please, please, please make sure that you are using your time effectively. So that way when I come in tomorrow, you guys feel pretty good and feel pretty confident on everything that we've done so far in this vectors chapter, so we can continue learning more about basics of vectors. Thank you guys for listening, and I will see you all in class tomorrow. Oh, and the other thing too, sorry, forgot to mention, tomorrow's tutorial. So if you're having a difficult time understanding anything that's been going on so far in our vectors chapter, please, please, please come into tutorial. Which I will be in room 101 for tutorial. So come on in and I can answer your questions then. Have a great day, and I'll see you all tomorrow.